now we're going to prove that Pascal's formula holds for any value of r where r and n are positive integers. Okay, now it's not going to be as easy as in the previous one where I could just easily cancel out the n minus 1s and the n minus 2s, because in this case I actually don't know what my r value is, but I can still prove it. So let's have a look. We know that our Pascal's formula says NCR is n minus 1 CR minus 1 plus n minus 1 CR. And we also know that NCR is equal to n factorial over r factorial n minus r factorial. So let's have a look at our left-hand side. We have NCR, and that's just going to be our n factorial over our r factorial n minus r factorial. There's nothing we can do about that. We don't know what r is. This is for any value of r. So let's have a look at our right-hand side. So what we have here is our n minus 1 CR minus 1 plus n minus 1 CR. And I'm going to put that into my formula. So n minus 1 factorial over r minus 1 factorial times n minus 1, now be careful, minus r minus 1 factorial, plus n minus 1 factorial over r factorial, and then n minus 1 minus r factorial. Okay, let's just see if we can put that up a little bit. So n minus 1 factorial over r minus 1 factorial, and n minus 1 plus 1 cancel each other out, so I just have n minus r factorial, and n minus 1, I don't think I can do anything with this one, r factorial, n minus 1 minus r factorial. All right, now I want to find a lowest common denominator, and it might be easier if I can try and include an n minus 1. I could rewrite this actually. Okay, let's there's some method in my madness. So if I've got r minus 1 factorial here and n minus r factorial here, and I've got n minus 1 factorial here, and I've got r factorial, and I'm just rewriting this as n minus r minus 1 factorial, because then you can see that n minus r factorial is actually n minus r times n minus r minus 1 factorial. Okay, and r factorial can be rewritten as r factorial times r minus 1 factorial. And the reasoning behind doing that is that it's going to make my lowest common denominator a lot easier to find. So, watch this. So, r minus 1 factorial stays, but I can write n minus r factorial as n minus r times n minus r minus 1 factorial. And then n minus 1 factorial stays, but I could write this n factorial, r factorial, as r times r minus 1 factorial times n minus r minus 1 factorial. And then hopefully you can see I have got that and that are common factors, that and that are common factors. So the only things that I need to multiply my numerators on to get to a lowest common denominator is going to be my r and my n minus 1. So that gives me r times n minus 1 factorial plus n minus r times n minus 1 factorial, and now I've got myself a lowest common denominator, and that's going to be r minus 1 factorial n minus r minus 1 factorial times r. Okay. And we know, now it can get a bit messy, we know that n minus r times n minus r minus 1 is just the same as n minus r factorial. And r times r minus 1 factorial is going to be just my r factorial. So I can rewrite it again. It looks a little bit messy. So we've got r times n minus 1 factorial plus n minus r n minus 1 factorial. Notice I can take out an n minus 1 factorial there, but that means I've still got r factorial n minus r factorial in my denominator. Let's take out that n minus 1 factorial in my numerator. So I've got n minus 1 factorial there. I've got r plus n minus r left there. Oh, probably not in red, but anyway. R factorial n minus r factorial, and r minus r cancel. So I've got n times n minus 1 factorial over r factorial n minus r factorial. And we know that n times n minus 1 factorial is just actually equal to n factorial. So that's equal to n factorial over r factorial n minus r factorial. Wow, and that's equal to our left-hand side.